Thanks for coming. So here I'm going to talk to you today about the Marco Polo Network. In the first part, I'll just go through a really simple example that explains what it is. We'll go into the technology choices, why we chose them, and then we'll go into our deployment and the design choices we made there and how we landed on GitOps. And finally, I'll open it up to the questions and answers. So the Marco Polo Network is best explained using one use case, which is called a three-corner or four-corner model. In a three-corner model, you have three participants. You'll have a buyer, a funder, or a supplier. One of our customers, DHL, is a big logistics company. They need trucks, so they go to a trucking supplier. They say, give us 100 trucks for the year. The trucking company will go back to them and say, that's 10 million, and the invoice due date is a year's time. So they do this, everything goes well, and then the next year they do it again, and for some reason the trucking company gets into cash problems, and they need the invoice honoured. The buyer, DHL in this case, isn't obliged to pay them. They can if they're nice, but they're not legally obliged to. So the trucking company will actually go to their bank, and they'll say, look, we have this invoice from DHL. It's due in 12 months. Can you honour it for us? And so they'll do their due diligence. They'll look at DHL. They'll look at the balance sheet. They'll see, okay, this is a profitable company, and they'll say, Grant, we'll give you 99 cents on the dollar. So the trucking company gets their cash when they need it. The bank makes a tidy profit, and the DHL continue to do business with the trucking company. So this at the moment is fraught with legal fees. It takes forever to process this one trade. It can be up to 2 months' work, and can cost somewhere in the region of 30 to 60 grand just for this one trade. And so at TradeX, we've already solved this, and we can, using Corda, automatically fund these requests. So we can connect banks directly to corporates and effectively process this trade automatically. And it doesn't have to be automatic, but they can have criteria and eligibility requirements and all this good stuff within the application. So that's the network, and you can see there on the right-hand side, you could connect feasibly multiple banks. So a corporate might, that trucking company might have 2 banks that they send that invoice to, and they can say, they can have banks effectively bid on that invoice so they can get a better rate. So it's opening up a new segment. So this is effectively what you'll see. The platform is the same wherever we deploy it. The way we configure it is through program configuration on the application, on the platform itself. So on the left there, you have the corporate platform, and the right is your bank platform. They're identical, except obviously just separate regions. And then in the middle, you have a co-located Corda node that has our own Corda app that connects via Spring Boot web API to our TIX API, TradeX API. And then using RPC, we can securely connect it directly to the Corda node and then out over AMQP and out over the Corda network. So this brings us to our technology choices. Docker, we chose it for many reasons. It's you can independently deploy it, you can independently develop it. Whatever container you're running, it can be created independently, basically. So the requirement for us is we need to scale the network from hundreds of nodes to thousands of nodes to like hundreds of thousands of nodes. And Docker was a clear choice because not only does it provide the convenience of being able to ship this to multiple customers, in on-premise managed service or in our own or in cloud, but it also opens up Kubernetes as well. And Kubernetes is just cool. We've a load of features we use for Kubernetes, but I mean, you've heard. I'm sure most of you have heard of Kubernetes and know why we chose that. So we're currently on AKS. So just out of interest, who here has used Azure Kubernetes service? Okay, and how do you feel about it? Yeah, okay. Yeah, it comes with challenges. We're on Kubernetes, AKS at the moment, and yeah, it does come with challenges, but I'll go into some of those later. But you know, we can see now coming down the pipe that we're going to be probably rolling our own Kubernetes. Going into a managed service has its own set of challenges, and we'd rather just roll it all ourselves. So Terraform then, why did we select that? Obvious one is the cloud agnostic stuff. We knew we were going into GCP and AWS, and we wanted one command that would basically not only be able to provision all the infrastructure, the underlying infrastructure, like your Azure databases, the IP addresses, the storage blobs, but also the platform itself. And we use that with a combination of Helm providers. So Terraform just allows us to build the underlying infrastructure as well as the platform using Helm providers. It's great because initially we were provisioning AKS with Terraform along with all the add-ons, and then we actually created a separate module for all the add-ons in anticipation for moving to separate Kubernetes clusters so that we could feasibly use the same Terraform module to provision things like your Nginx ingress controller or your FluentBit or whatever add-ons we need to do the deployment. And then Helm was a choice because anybody who has core Kubernetes knowledge can work and understand this. And our security, we have Twistlock, which gives us a great bit of container scanning. It's cool because it actually contains, it can scan distroless containers. And we can optionally run it on PR or build time, and it can also be run against the Azure Container Registry. The same for Sonar Cloud and Black Duck. They follow the same process. We can run these at, on release containers, or release candidates, sorry. And yeah, it gives us our static code analysis and license compliance. And then Vault, security is obviously top concern, and storing secrets securely is massively important for us. So Vault facilitates state-of-the-art stuff with very detailed access policies, and it's integrated with AD, and it's cloud agnostic as well. And all of these tools are rolled through GitOps. So we use Terraform and GitOps to deploy these. So we're not stuck for cattle versus pet stuff, and we're not stuck manually provisioning anything. We've kind of had a lot of effort to build these automatically. So Thanos helps us to distribute the load to multiple Prometheus installations, and these are built alongside our Kubernetes clusters. So you'll have a Prometheus server on every Kubernetes cluster. And it also gave us the ability to deploy Prometheus in HA mode, and we use Azure Blob as a centralized store for basically the data. FluentBit and FluentD were chosen because they have a tiny footprint. FluentBit gives us per node log collection, and then FluentBit delivers to the upstream aggregator FluentD, which then provides that multiplexing and the initial processing of logs, which are then delivered to Graylog and Elasticsearch. So that brings us to the deployment, and our deployment is, we need to deploy to thousands of platforms worldwide, hundreds of thousands and millions. Some people in the company will have you believe, but for now we're focused on thousands or hundreds of thousands. So we needed this to be fully automated. We needed to be traceable, audited. We needed to be able to roll back just a bunch of things, which all kind of pointed towards GitOps, which is what we ended up as our main deployment workflow, I guess. and utilizing all the technologies, Terraform, Kubernetes, Helm, we've effectively built a GitOps workflow. So that basically looks something like this. So in 3 different distinct areas or types of environments, you may have dev, non-prod, and prod. And a developer will come along in this dev environment and they'll push a change to GitHub. Jenkins will pick that up, do a git checkout, and Terraform plan. And sometimes we see these fail, 2-3 times in a row until they find out any syntactic errors or just, they've spelled something wrong. But it's on the job of the reviewer to look that the plan has been successful, and confirm that the plan isn't going to remove resources that it shouldn't be removing. And once that's all good to go, there's an approval, and then Git and Jenkins work together automatically and pick up that latest merge. Basically, we'll do a plan and apply those changes. That happens in dev, and then it moves into non-prod where you do it again, and then into production. So you're stepping into production gradually, and you can see the history of changes. So this is a sample PR. It's an old PR, but it is, it's one of the Corda Global Trial banks that are, trialing the application at the moment. So up the top you see there, we define Lloyd's Bank, what module they have. So we have a bunch of modules in development which provide different features and different application features. So we have the ability to specify there what type of module they get, and then the sales team and the licensing team will be delighted with this because they'll be able to see which platform has what module. You can specify what the domain name here is. Your X500 name there is your Corda legal name. And you move on down to the middle part of the file, which is your line 47 there. You have all those components in the application are independently deployable, so we can also version them independently and deploy them independently. So as you go through, bug fixing or whatever, if there was a certain bug on Corda chart, you could upgrade that to 151 and not have to deploy anything else. So it's GitOps will automatically recognize that this has changed, and it will only change the components that need to be changed. And then, this is where we specify what the network is. So at the moment, that's on the Corda UAT network. And, we'll be able to specify here prod network, or if there are many different business networks in Corda, we can specify which one. And then we specify some backup stuff as well. So that's your dev pipeline, really simple. You just, the first part, you have a plan fail, and then you move through to apply, and then you back up your Terraform state each time. So we have had instances where our Terraform state has become corrupted and we've had to go backwards. So the Terraform state is actually stored remotely, and only the automation is allowed to speak with it or to interact with it. It saved our bacon a couple of times. And then all that file will basically provision the entire Marco Polo platform. So you have all your services in the middle, your Rabbit cluster, your Corda integration client in Corda, and then you have your non-Kubernetes components like your Azure SQL Elastic Pool and Azure File, Azure Cosmos, Azure Active Directory. Down the bottom, you have all your Prometheus, node exporters, Fluent Bit, and then the left, you have your cert manager. And like this section here is all built by that Terraform module prior to being laid down. So the AKS cluster is laid down first, then you lay down your add-ons, and then while you're building the platform, you lay down your Azure components. And it works amazingly. Kudos goes to my team who've put this together. Radek, Krish, Claudio, Mache are not here, and they've really done an excellent job of putting this thing together, and it works like magic. They wouldn't have me believe that, but it does work like magic to me. So So the lessons learned, managed services, as I said earlier, they don't take the headache away. They've added some complexities and kind of added a wall where we need to see what's happening. So Azure have been quite helpful with us. We have fast track support, and we're upgrading our support model because we really do need their help in a lot of places, including storage. One of the issues we ran into when using Terraform against the Azure API was that we were throttled a lot. So we had to actually fan out and move into different subscriptions, and we were calling it like walking on snowshoes, basically, in Azure, because it couldn't handle the load. You have something like 12,000 API requests per hour. So we were hitting that, and then you just get throttled. And of course, Terraform requires access to the API, and if it's being throttled, it can get into some weird failed states. Storage is quite hard in Azure as well. We found that a lot of the AKS, PVC, and Azure API backend integration it doesn't seem to detach and reattach disks successfully. So we've had to kind of mitigate that by doing some kind of silly stuff. But yeah, it's just part of it, and they're kind of working on a lot of those issues at the moment. And then fix it yourself. This one is about the helm providers, which is again another challenge with Azure. So as you're using helm providers, they may push a fix or push a change to their API that breaks a certain version of a helm provider, or breaks a certain Terraform Azure integration, and then you're basically unable to do something that you were able to do before, and you don't know why, and you have to go and investigate, and then you find in some GitHub issue that, yeah, this is broken. So that's just a part of the challenge. And then this is a kind of a sneak peek at the Marco Polo global trial. So we've built in 15 or 11 different regions. It would have been more had AKS actually been available in all the regions. We would have been up to about 20 or 25, but AKS is being rolled out in a bunch of different places, so that's kind of been limiting us to a certain amount of regions. But yeah, you can see we're kind of geographically dispersed, and it was all built using GitOps. And obviously we discovered a lot of issues as we were building this, but if we were to do it again now, I could comfortably say we could do it in about 2 or 3 days and build hundreds, if not thousands, of platforms, pretty easily. So yeah, that's it. Thanks. Open up to questions.
Awesome, round of applause. Oh, great, there's more people. Okay, so there's 2 questions. So we'll go for there's one logging and monitoring question. So you kind of talked about the stack you used. The question is talking about how do you reassure customers about the centralized logging functionality within a decentralized platform?
Yeah, it's a good question. So in our case, it's twofold. Some customers do require segregated logging, segregated everything. Some customers don't. It's just a tier of customers that require that their logs be kept basically segregated from everyone else. So, with GitOps, we can provide them. It obviously costs them extra money, right? But we can provide them their own logging solution. For on-premise customers, we have offered them to, this is what we use. We give them recommendations. We won't build it for them, but we'll give them recommendations on how to set it up. And then they'll have it on-premise, and it'll be their own dedicated one. For smaller corporate customers, you'll have, that stuff can scale. A mom and pop or a smaller corporate may not even care where their data is, just so long as they can push their 100 or so invoices a year. It's not a massive deal to them.
Another one's quite interesting here because of the deployment stack, so Docker and the tools you're using right now. How do you manage Corda updates or upgrades? Do you deploy the whole, Docker image with Corda runtime, or is it just the Corda app that you're deploying?
So again, we do both. We have, and Chris Sharada could probably answer better than me here.
We deploy Corda apps inside the Docker image. So, and then we are in the process of running a code. So basically, during the upgrade process, we might need to drain the node, or we might need to do some admin operations. So we are deploying a Corda integration client just for admin purpose to do this training node and all this stuff. So basically, we are deploying Corda apps with Docker image for managed services, but for the banks and everything, we provide the Docker, just jars
files, yeah.
using the Artifactory.
Yep.
Hello. Yeah, that makes sense. Just seeing about 20 questions just come up now. So I'm going to pick a few. This one's a question I kind of had as well, which I was thinking in my head. So why do you deploy so many instances? So isn't Marco Polo a decentralized distributed platform with nodes being deployed by the participants as opposed to by yourselves?
Well, it's both. So we have three models, right? We have the on-premise, cloud, and then a managed service. Managed service is obviously the cheapest model that we have, and that's where we'll deploy, at scale, and we'll do, pretty nifty things where we can get away with it, in terms of sharing infrastructure. But yeah, that's basically the three models you have. We can do all three effectively.
Okay. Is there any plans for multi-cloud instances?
There is.
And
yeah, so AWS and GCP is up next for us. Yeah.
So that means how you orchestrate Kubernetes for multi-cloud, you'd have to restructure that for...
I might jump into that. We're actually designing all the platform and all the deployment for Kubernetes specifically. So we don't look at Azure or Google or something different as like completely different targets for deployment. From our perspective, they are mostly just Kubernetes clusters. So when we have a client that wants to deploy an on-prem, just have a Kubernetes cluster that supports all the major Kubernetes features, like attaching volumes. One thing that we are actively using now that is Azure specific is Azure SQL Server. But obviously, you can easily deploy a MS SQL cluster within your infrastructure and just forget about that part. So our development environments run with MS SQL on containers. They run with MongoDB on containers. Azure deployments run with Cosmos DB managed service. So it's kind of like the Docker's philosophy, but there is included but swappable. Most of those things can be exchanged for something different, and it just works. You just drop it on your cluster. It's a Helm release, so just provide proper connection string, and that's it.
Awesome. So some great answers there. There's still a lot of other questions here, but what I would encourage you to is go on the app, ask a question directly to Dan and the team, where you can actually send them a direct message to follow up on this stuff. It is lunchtime now, so
no questions then.
Yeah, so no more questions. But yeah, round of applause for Trey and Dan.
Thanks.